approximate definite integrals with a certain number of subintervals. It's a very good method. Okay, so let's look at 28 on 389, right?
Yes.
Okay, perfect. So total cost from marginal cost, fine. Manganiello, I think, Paving Incorporated, has found that the marginal cost in dollars of paving a road surface with asphalt is given by. So they found the marginal cost, which is the derivative of the cost. 16x squared, bless you, minus 20x plus 1800, I believe, for x less than or equal to 80. Where x is measured in hundreds of feet. Okay, use 4 subintervals over 0 to 40. This is our A and this is our B. And n equals 4 subintervals. And the left end point of each subinterval to approximate the total cost of paving 4,000 feet. So 40 is in hundreds of feet, so 4,000 feet of road surface. Okay, so they want the left end point. Good. So I don't need to graph the function. All I need to do is realize that this is the interval 0 to 40. They're asking us to divide it up into 4 equal subintervals. Here it is. 10, 20, 30. So the area with the left 4 will be approximately, what is the width of the base of each rectangle?
10.
Very good. So if we are using the leftmost point, I have to write C, the function C prime of 0 plus C prime of 10 plus C prime of 20 plus C prime of 30. What would I have done for finding the same thing with the rightmost point? I will still have 10, but I will have C prime of 10 plus C prime of 20, C prime of 30 plus C prime of 40. What if I was asked to find a midpoint? Then I would have said 10 f of 5 plus 10 f of
15
plus 10 f of
25
plus f of,
35.
then this would have been the best approximation. Also, after we are done with this, we are going to find the exact area. Why? Because we know how to find the antiderivative of this function. It's not going to be a problem. Ready? Okay, very good. So what I would recommend is let's put in this function in the graphing calculator and quickly determine all those. So clear whatever you have in there. So this is 1 divided by 6. I prefer to put in parentheses 1/6, and then x squared minus 20x, and then plus 1800. And please go to second table. I have another calculator if anyone wants to use it. It's right there. If you, Emily, if you want to give it to Brian, if he wants to work on that. So second table. So I have 0, and I have 10, and I have 20, and I have 30, and that's it. I'm going to add up all these and multiply the result by?
4. No,
By
40.
By 10.
10.
Right?
Yeah.
So these are all in parentheses that I had, f of 0 plus f of this plus f of that. So this will be 10 multiplied by 1800 plus 1616.7 plus 14667 plus 1350. I have a way of summing those up, but I have to put them in a table, in a different table. Okay, so 1800 plus 16.7 plus 1466.7 and plus 1350, right? I sum them up and I multiply by 10. And what do I get? 62,334. 62334. So I was given the rate of change of cost with respect to units of feet of asphalt. Yeah, with respect to feet or distance.
Is it cost per 100 a foot?
So this is the cost, the total cost between 0 and 40, which means building or laying asphalt for 4,000 feet. This is the cost. And let's read the question one more time. To approximate the total cost of paving 4,000 feet of road surface. So that's the length, but I don't know how wide, because it could be 4,000 feet, but it could be on 6 lanes. So the price is 62,000. I don't know.
That's very interesting.
Is it clear? So we were given the rate of change, and from that rate of change of cost with respect to feet, we were able to determine the total cost by simply finding the area under the graph. Now let's determine the exact. So we wanted to determine the exact. I will determine the total cost will be the integral from 0 to 40 from 1/6 x squared minus 20x plus 1800 dx. Remember, this is exactly the same thing. How come? It's all these times dx. That's your dx. Okay, so can anyone give us the antiderivative of 1/6 of x squared?
1/18x.
X cubed divided by 3. That's perfect. Minus 20. Very good. Very good. No need because it's definite integral. I don't have to plug in 0 because when I plug in 0, everything happens to be 0. All I have to plug in is 40. So 1/18 times 40 cubed minus 10 times 40 squared plus 1800 times 40. So with the graphing calculator, I thought I had a number. Yes, I do. So let's see what we get. So 40 cubed divided by 18 minus 10 times 40 squared and plus 1800 times 40. Okay, so the exact cost is 5955556. This is the exact cost. We knew that the answer we got with the leftmost point or the rightmost point or the midpoint could not be 100%. This is the 100% correct answer. 59.
Work to get there.
It's not. Yes, April?
So I have the area from the leftmost point.
Using the leftmost point.
Using the leftmost
Yes.
point would normally give us an underestimate.
It's an excellent question. It
Okay.
depends on the function.
Okay.
If the function opens up, the leftmost point will be an underestimate. But if the function opens down,
It's gonna be an overestimate.
it's going to be an underestimate.
Oh.
Very good question. Excellent. Well done. Yes, it depends on the function. Yes. One or the other will be an underestimate or an overestimate, and the midpoint will be the best approximation. Excellent question. Thank you. Okay, Doing anything else from here, or we proceed?
So why did they give you the information x is less than or equal to 80? What is that?
Very good. Because they determine the function, the rate of change of cost with respect to feet of asphalt for anything under 8,000 feet. It's 80, 100. So yes. So because if they exceed that, it's possible that the cost function, the rate of change would, or the marginal cost would change.
Okay.
Normally, the higher you produce, the less cost you have per unit. Normally. So they just determine between 0 and 8,000. This is the rate of change. I don't know, between 8,000 and 40,000, the rate of change of cost may be different. That's what they said, less than or equal to 80, which is less than or equal to 8,000.
Okay. And then they're asking you to approximate the total cost of paving 4,000 feet. Is that the 40 you just said?
Yes,
Okay.
yes, between 0 and 40, which means, yeah, because X is given in hundreds of feet, yes. Good, other questions? Okay, because now we have an idea what the integral means, one more time, definite integral is something with limits of integration from f of x dx, which is a number always. The indefinite is the integral from f of x dx, which is a function. When we do not have limits of integration, the answer is a function. So what's the difference between these two? Many differences. This is an area under the graph between such and such, and this is a function. Now, which of these two I can check? One of these two I can always check. The other one, never.
The top one you can check?
Never.
Oh.
I can never check this. You can only trust me that it's 59,555.56. There is no way I can check. I can go back and redo it, but I cannot check per se. This is the only one of the two that I can always check. Here's why. Let's look at an example. Let's say the integral from, give me a function, any function you want.
2x plus 3.
Oh, good, a simple one, very good. That's perfect. So this is 2, x squared over 2 plus 3x plus a constant c. And after I simplify, I will write the integral from 2x plus 3 dx equals x squared plus 3x plus c. Would you agree? So far.
So why did you do the 3x? It wouldn't be 2x over 2 over 2? Because
So-
2 plus 3. 3 right now is your constant on the left.
Right. So when I differentiate this, I get 3. When I differentiate this, I get 2x.
Yeah,
When I differentiate this, I get 0.
gotcha.
Okay, perfect. So now, I'm not done. I'll come back in a second. I just want to mention something. Something that we've been using already is called fundamental theorem of calculus. Fundamental theorem of calculus. It has part 1 and part 2. In some books, this is 1 and 2, this is 1 and 2. It doesn't matter. The first one is that we already used is this. Can anyone give us this result?
B minus A.
Yes. F of B minus F of A, where F, uppercase F, is what?
Greater than
The
0.
antiderivative of this is the function that I differentiate to get F. And here's the second part of the theorem. Differentiation and integration are dot, 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 and you'll tell me what to put in there. I'm missing a word.
Complex.
Good try. They are inverse operations.
Sounds complex to me.
Okay, so let's make Angel happy. And complex operations as well
You're the best.
by Angel. Very good. So, coming back here. In other words, I'm telling you that if I differentiate this side and I differentiate this side, I have to get a true statement, which I cannot do with a definite integral. How come? Well, when I differentiate this, I get 0. When I differentiate this, I get the function. So I can't do it here. So let's differentiate this side. When I differentiate an integral, this is what happens. The integration goes away. So the left-hand side is 2x plus 3. Does it equal the right-hand side? Of course it does. Because when I differentiate this, I get 2x plus 3. Any questions? I would like to look at a few examples with indefinite integration, because we have not done that. And Emily is way ahead of us. She has done everything from that section, and I didn't even got the chance to show one example. Okay, so on page 378, let me choose, because I don't want to choose the ones with substitution yet. So allow me to choose. So let's start with 21 on 378. The integral from 3 over x plus 5 over x squared dx. Are we going to get a number, or are we going to get a function?
Function.
Awesome. Whatever function I get, is there a way of checking whether the function I got is correct?
Yeah.
By differentiating both sides. Excellent. Because this is an indefinite integral. Very good. So 3 is outside, but now I would like to know what function, what do I write here, whose derivative is 1 over x? Yes, it's right there. Excellent. This is the only one I cannot use the power rule on. Now plus 5. Remember, it's wise to change this into x to negative 2. So it will be times x to negative 2 plus 1 over negative 2 plus 1 plus a constant c. That is the easiest thing to do. Yes, I have to clean it up. How much is negative 2 plus 1? Good. So then this becomes 3 natural log the absolute value of x minus 5 over x plus a constant c. Because this is x to negative 1, it goes to the denominator. This is negative 1 times 5. It's negative 5. If I want to check, let's differentiate this. 3 over x, good, minus, so this is 5 to negative 1. I bring down negative 1 and I subtract 1 from the power. And the constant prime is 0. And this is exactly what we started with. Any questions? Any questions? I do not want to choose e to the x just yet. We'll get to that. but I like to choose 42. In 42, we want the integral from x plus 4 squared dx. We have to expand this, and we have an agreement that we signed on the first day of classes. When I expand x plus 4, how many terms do I get? Very good. X squared plus 8x plus
60.
Excellent. Dx. And now there is no problem. I have x cubed over 3 plus 8x squared over 2, or 4x squared plus 16x plus c. Is there a way of checking this? Yes. If I differentiate this, I have to get this function. I bring down 3, subtract, simplify, I get x squared. I bring down 2, multiply, I get this. I differentiate this, I get 16. I differentiate c, I get 0. So this is kind of user-friendly. I can always check. Any questions for me so far? Yes?
Why is it 4x squared?
Because it's 8x squared over 2, and I simplified 8 and 2, and I got 4. That's okay. That's okay.
Not like in this chapter.
Okay, now I would like to look at a word problem for this. Pages 379, 380, 381. So let's see what we are interested in. Yes, supply from marginal supply. Memory. Because we have not gotten the chance to we'll look at word problems from this section. Memory, population growth, physics, height of an object, heart rate. Okay, I don't want to do the heart rate just yet because of the function. I need to show the substitution rule. I don't want to just have you guess. So let's make a note. Please make a note anywhere that we have to go back to problem 69 on page 380. Don't let me forget. But I have to present the substitution rule first. So what about population? I'm sorry. What about
What page did you say?
379, 378, and 380.
Okay.
Can we do the memory one?
The memory, very good. Let's do the memory. 70. 70 on page 381. I'm lying. 380, sorry. Let's read the problem. In a memory experiment, the rate at which students memorize Spanish vocabulary is found to be given by the rate of change, m prime of t, equals 0.2 t minus 0.003 t squared, 0.003 t squared, where m of t is the number of words memorized in t minutes. Find m of t if it is known that m of 0 is 0. M of 0 is 0. Find m of t. I am given a derivative of a function, and I'm asked to find the function.
So we need to find the inverse.
I need to find the indefinite integral, the integral from m prime of t dt, which is the integral from 0.2 t minus 0.003 t squared. Remember, no integral exists, definite or indefinite, without either dt or dx or dy. This must be in the problem, as well as the function. So now let's determine the antiderivative of each piece. So we have 0.2 t squared over 2 minus 0.003, and what do I write? Over 3 plus a constant c. I will simplify and get 0.1 t squared minus 0.001 t cubed plus a constant c. However, we are given the information, this will be m of t, but we are given information that m of 0 is 0. Why is this piece of information given to us? In order to help us do what? Find the constant. But when t is 0, 0, 0, and the answer is 0, how much is c then? Do you agree with 0? Yes, everyone? Okay, so then m of t is 0.1 t squared minus 0.001 t cubed. So we were able to determine a function that gave the rate of change. And from that rate of change, we were able to integrate indefinitely to determine the function. Part B. How many words are memorized in 8 minutes? So let's make sure that x, t minutes, correct. So how many words are memorized in 8 minutes? What am I asked to determine in part B? M of 8, very good. So 0.1 times 64 minus 0.001 times 8 to the third. I don't know if I can memorize that much. I don't know. 64 minus, let's see. I hope they don't say 100, because I don't think I can memorize 100. Okay, oh, so 5.8, so approximately 6 words. Very good. Do we understand the difference between the definite and the indefinite integral? The indefinite integral gives us a function that we can work with for other purposes. The definite integral always gives us a number. Gives us a number that we are interested in. Okay, and then we looked at 4.2. And we had applications. We are ready now to work more on 4.3. Ready? Okay. So on page 402, please choose anything you would like from 43 through 58, and then let's look at the word problems. 402, 43 through 58, and then please choose a word problem to illustrate more of definite integrals.
Can we do 56?
Of course, 56 it is. Perfect. 56 on page 402. And we have the integral from 1 to e. No, of course I copied something else. I copied 55, I'm sorry. From -5 to -e. -5 to -e from x minus 1 over x dx. Good. Which function prime is x? Good. Minus. Which function prime is 1 over x? Of the absolute value of x. From -5 to -e. We are using the fundamental theorem of calculus part 1 that shows us how to evaluate a definite integral. Perfect. So now we plug in the top first. So when I plug in -e and I squared, it's just e squared over 2 minus. When I plug in -e in natural log, I'll see in a moment, it's just going to be 1. Yes, because this is the absolute value, so it's going to be e. Natural log e is 1. So let's continue. Minus. Open parentheses so you don't forget to distribute a negative sign. Let's plug in -5. Well, 25 over 2 minus natural log of the absolute value of negative 5. Are these steps clear? Yes? So we plugged in negative e, and then we have to subtract when we plug in negative 5. So that's why I had to open parentheses, not to forget to distribute negative 1. So now we have e squared over 2. This is natural log e, which is 1, so minus 1, minus 25 halves. Then I have to distribute, and it changes to plus. And this, the absolute value of negative 5 is 5, so this is natural log 5. You can, if you want to, find the least common denominator. It's not going to make a huge difference. So e squared minus 2 minus 25 is minus 27 plus 2 natural log 5 over 2. We can choose something else, or we can look at the word problems now.
We did another problem.
Like this one? Yes, yes, of course.
Can we do the cube root, I guess, 46?
Yes. You said 46?
Yes.
Yes, the cube root of x minus 2. Perfect. The cube root of x minus 2. So this is 46 from 1 to 8. And of course, dx. Do we understand the previous example?
Yes.
Okay, perfect. So remember, of course, I want this to be x to 1/3 because it's easier to calculate the antiderivative. Yes?
Yeah.
Very good. So then I have x to 1/3 plus 1 over 1/3 plus 1 minus 2x from 1 to 8. Again, this is the fundamental theorem of calculus part 1, in which we are finding the antiderivative, and then we will plug in 8. The denominators are going to be 4/3, but I flip it into 3/4. And the numerator, I mean not the numerator, yes, the numerator will have the power x to 4/3 minus 2x from 1 to 8. So I plug it in. 3/4, 8 to 4/3 minus 16 minus parentheses so I don't forget to distribute. 3/4 minus 2. Before we calculate anything, let me know if this is okay. Is this okay?
Where did the 3/4 minus 2 on the end come from?
So this is the most general antiderivative. I have to plug in 8, and then I have to subtract when I plug in 1.
Oh, okay.
When I plug in 1, I get this piece. So the cube root of 8 is 2, but this is 2 to the 4th. Or, I hate to do this with a calculator, but I'm not sure whether you remember this. So I have 8 power, because it's the cube root of 8, which is 2, and 2 to the 4th is 16. But let's do this. Power in parentheses, 4/3. So when I click enter, I have to get 16. And I do. So this is 3/4 times 16 minus 16 minus 3/4 and plus 2. I'll simplify by 4. So 12 minus 16 minus 3/4 and plus 2. So this is negative 4. Negative 4 plus 2 is negative 2. Negative 2 minus 3/4 will be negative 11/4.